Although most activities in the countryside this year suffered to some extent due to the outbreak of foot and mouth, the LMA were able to successfully stage most of their planned venues. The footage for this programme was acquired at the larger events held at Southport, RAF Cosford, Carnarvon, RAF Woodvale, Rufford and Catton Hall. Additional filming was obtained at smaller club meetings. The expert flying of these superb models represents the pinnacle of modern aeronautical engineering, and the enormous public interest in such displays can be judged by the fact that between them the Cosford and Woodvale rallies attracted 100,000 spectators. The models featured in this programme replicate the development of the model aeroplane from almost the dawn of flight, through the last 90 years of the 20th century to the latest frontline jets. The two great world wars, which marred the 20th century, provided the momentum required in the development of faster, bigger, stronger aeroplanes. This in turn led to new materials and a wide range of previously unknown technologies. Just as in full-size aviation, so there is now a vast range of materials and technologies available to the modeler. Such advances enable these big model aircraft to be constructed and flown with safety as a major priority, at a distance from which the spectators are able to appreciate the skills of the pilot and the wealth of scale detail so evident on the models themselves. The model aircraft hobby has come a long way since the days of balsa, tissue, rubber bands and small high-revving engines. Glass fibre, carbon fibre, polyurethane foam and specialist adhesives are now available to the modeler. However, it is significant that many of the enthusiasts from very early aircraft still endeavour to use the same materials to replicate exactly not only the external surface detail but also the airframe construction of the full-size subject. Today there is a wide selection of large, powerful engines, specifically developed for use to power these large model aircraft. Additionally, model jet turbines, superbly manufactured and using very high-tech materials, are now available. The impeller shaft of these gems of engineering rotate at up to 150,000 revs per minute. However, it is probably in the development of electronics which has brought about the greatest advances. The sophisticated radio control systems of today allow these models to be flown accurately and therefore safely. This programme will illustrate the wide range of interests of members of the Large Model Association, together with their professionalism and enthusiasm when displaying their aircraft in front of the general public. We now meet Tony Fisher, Chairman of the Large Model Association.
Hi, my name's Tony Fisher. I'm the current Chairman of the Large Model Association. The association was formed back in 1982 to represent the enthusiasts in the hobby and enable them to fly and build large model aircraft and operate them safely. The association was actually set up to promote the safe operation of large model aircraft, to run fly-ins and public shows on behalf of its members. Safety is of the paramount importance to everyone concerned with this hobby. The pilots, before they're allowed to fly in public, have to go through a proficiency scheme to demonstrate their capabilities of operating a large model safely. The association doesn't ask for modelers to perform precise aerobatics. In fact, we welcome along the average pilot as long as he can operate a model safely then he would be more than welcome to fly with the association at any time. Structure integrity of models is also very much at the forefront of the association. We are charged by the Civil Aviation Authority to inspect models over 20 kilograms, both during the build and the final inspection prior to flight. We also put them through a simple test procedure to make sure that the models are acceptable to flying in public. The LMA is not an elitist organisation. We would welcome anyone who has even the smallest interest in connection with aviation.
In 1910, the Avro triplane was the first British designed and built aircraft to fly in England. It proved to be difficult to fly, and after a number of crashes, in particular on 2 occasions into the sewerage farm near its base at Brooklands, it was dismantled later the same year. This half-scale replica, built and flown by Ian Tony White, is based on a full-size replica constructed for the film Those Magnificent Men in Their Flying Machines. Its wingspan is 15 feet, its length the same, and it stands 5 feet high. Total weight is 120 pounds, and the model is powered by a German Solo single-cylinder engine of 212 cc. The airframe is constructed exactly as the original, from spruce, ash and birch ply, and incorporates over 200 turnbuckles and nearly 400 brackets. Banking and turning are accomplished by warping the 2 upper wings, together with judicious dabs of down elevator. In Ian's own words, it flies like a pig, just like the original. However, the model is still being flown after 10 seasons. In the early days of aviation, the triplane, and in particular the biplane, dominated the scene. In this display of World War I aircraft, there are 15 models being flown, representing types used by the British, French and German air forces. This chaos, which started the LMA display at RAF Cosford, in many ways faithfully reenacts what would have occurred over the battlefields of Flanders. The flight line is also a frenetic scene. 15 pilots, each with their own helper, attempting to avoid other aircraft, and even more importantly, trying to keep their own eyes on their own aircraft. The models have very similar flying characteristics as the full-size aircraft. Being of light construction, they tend to bounce around in flight, especially in turbulent conditions. For the same reason, these aircraft are difficult to handle on the ground during taxiing, takeoff, and in particular during landing. This display is orchestrated by Peter Latham and demonstrated by the enthusiastic members of the World War I Flying Circus. Peter is also the secretary of the LMA Proficiency Scheme, and he organises and with other members tests and advises new pilots prior to them flying their models in front of the general public. Ian now describes another of his models, the Newport 28.
My name's Ian Tony White, and we're at Woodvale this year, 2001. I'm sat in front of my half-size Newport 28, which was built in, the original was built in 1917. It was built by the French, and I think they built about 300 of them. But because the French had the SPAD aircraft, they didn't use it themselves, and they sold them to the American Expeditionary Force, and they flew it quite a lot. There were some problems with the full-size aircraft. The fabric used to come off the top wing, which was quite worrying, and the other problem was the engine didn't have a throttle, and the only way you could slow the engine down was to switch the ignition off to a number of cylinders. The only problem, if you did that for very long, the unburnt fuel used to collect in the crankcase, and the engine used to catch fire, which was the last thing you wanted. After the First World War, quite a few were taken to America, and they were used in some of the early aircraft movies, films like Wings and that, which were quite popular in the day. This particular aircraft was stored in varying degrees of sort of states, and it actually came to England in the early 90s, and a company in Bedfordshire completely rebuilt this aircraft, and it was flown again about 1995. I actually swapped videos with the owner of the company, a chap called Tim, and it was quite interesting to look at the full-size one flying, and it was very much like the model, really, in a way. Had quite a fast climb, quite a fair turn of speed, and it certainly didn't hang about. It wasn't a gentle aeroplane by any means. I talked to the pilot as well, and the original Gnome engine was rated at 160 horsepower, but when he flew it, he said it felt more like 300 horsepower, and he was always very, very pleased when he got the thing back on the ground again. I copied the colours that they used, which is an authentic colours from the World War I, and the model's really based around the Westlake engine in the front, and that was used as a target drone engine, and in fact you can see between the cylinders at one side where a bullet's gone through, luckily without doing any real damage. It's got a 41.25 inch propeller. You've got a lot of torque reaction with the engine. The model's maybe a little bit overpowered, but it goes well enough. It's built up from clear Colombian pine, which I cut from some big planks, ribs of balsa, ply cap strips. Generally a built-up construction. The struts and the undercarriage are from ash with stainless steel metal plates, and the model's got an inner frame for the fuselage with part formers, which accepts the ply covering at the front and the stringers at the back. I think it weighs about 120 pounds, and it doesn't like concrete. You think you've got it down safely and it's almost stopped, and as the tail gets down and you sort of try and kill the throttle a bit more, the torque reaction, the difference in it, spins the thing round. Much better off grass. It's a bit intimidating to fly. It's a bit of a beast to fly, but as I say, I think the full-size one was just the same. I think it makes a nice display model, but I think next time I might build something that's a little bit easier to fly.
We now see Jeff Pearson's half-scale Bucker Youngmeister. This biplane dates from the mid-1930s and was originally designed as a trainer for the Luftwaffe. It was almost immediately recognised as an aircraft with great potential, not only as a trainer, but with some minor modifications as a full aerobatic machine. As such, it took the aviation scene by storm, and even today is still much sought after. The full-size aircraft, which was the subject of this fine model, is now on display at the Smithsonian Museum in Washington. The model is 9 feet 6 inches in wingspan and weighs 55 pounds. The airframe is constructed from hardwood, spruce and balsa. The engine is a 120cc McCulloch racing go-kart engine. Radio control is by JR with 2 onboard receivers and the normal heavy-duty servos and fail-safe equipment. One unusual feature is that the upper and lower wings are interchangeable, as on the full size. The model flies just like the real thing, and Jeff reports that it is capable of manoeuvres beyond his actual ability. But because the model is so genuine with its flying characteristics, it is in fact encouraging Jeff to become more daring. This wonderful de Havilland Dragon Rapide was featured in last year's programme. Built and flown by Ted Allison, it deserves a second showing. The Dragon Rapide was designed in 1934 as a small commercial airliner and carried up to 8 passengers on routes between major cities in the UK and in many countries throughout the British Empire. During World War II, these aircraft, renamed as the Domine, were used as flying classrooms for the training of navigators and also to ferry RAF aircrew between distant airfields. A small number are still flying and used for pleasure flights. The model is built at 1/3 of the full size and over the last 3 seasons has completed over 90 flights in front of the public. It is without doubt one of the favourites with spectators. The elegance of line, so obvious on the ground, becomes even more apparent in the air. The wingspan is 16 feet. Its weight a very creditable 105 pounds. The power is supplied by 2 3W 60cc engines, giving approximately 11 horsepower in total. The radio control is by Futaba, with 2 onboard receivers and backed up with a fail-safe system. A total of 14 high-power servos operate the flying controls. The main materials used in the construction of the airframe are plywood for the main formers, together with cypress spruce for spars and stringers. The wings are polystyrene cores with balsa cappings to simulate the wing ribs. The flying wires are all load-bearing and made from steel, which in real life has been developed for the drain clearing industry. The width and thickness of the strip was found to be exactly to scale. The model took 3 years to construct, and this was in part due to Ted having access to a genuine repair and maintenance manual published in 1945. From this, he was able to glean a great deal of detail, which was then reduced down to the scale of the model. No changes were made to such important features as the airfoil sections on the wings and tailplane, so that the model has inherited all the flight characteristics of the full-size aircraft. One of these is a dramatic tip stall when banking at relatively low airspeed. A feature of Ted's display is that the model is always flown at a safe height and, more importantly, a safe attitude, just as the pilot of the full size with the added responsibility of carrying passengers would have done. This most impressive aircraft is, in Ted's own words, an absolute joy to fly. We now see a superb model of a unique 1930s biplane. This is Dave Horton's 1/3 scale model of a racer designed by Howard Hughes to compete in the Thompson Trophy races in America. Hughes named it after his girlfriend at the time. The aircraft was in fact built in 1933 by Boeing to Hughes' drawings, and it was the last really competitive biplane. But although very fast, it couldn't match the monoplanes flown by some of his wealthy competitors. The model has a wingspan of 11 feet and an all-up weight of around 70 pounds. Dave, a stickler for scale detail, has completely enclosed the 45cc Super Tiger engine, which powers the model, and constructed a superb 1/3 scale Pratt & Whitney radial engine, using some very unusual components. For example, The cylinder bores are 1 3/4 inch plastic drain pipe from B&Q. The cylinder cooling fins are rubber matting used for covering car running boards. The bulbous crankcase is a plastic Tupperware bowl. The exhaust cooling fins are contact lens cleaning stands. The cylinder heads are from scrapped Enya 40s. And finally, and the most expensive part by far, the sparking plugs. These are from old Frog petrol engines, bought for £90 at a bring and buy sale. The propeller is a commercially available dynathrust, considerably modified so as to be exactly to scale. In order to give the model a more authentic sound, the exhaust fitted to the Super Tiger has been modified internally by the addition of brass reeds. Dave says the model handles beautifully, just like a true thoroughbred. Staying with biplanes, we now see the Supermarine Sea Otter and meet its creator, Roger Bale.
It was built by Supermarine at the late end of the war, and in actual fact came out around 45-46. They were of a larger engine. It wasn't a pusher as the Walrus was. It had a puller on the front, a larger radial engine and a Bristol engine, and because it was more powerful and a slightly larger body, instead of like the Walrus would land in the sea, pick up the downed air crews or the whoever, and then it would sometimes have to taxi all the way back to the port because it hadn't the power to take off. And so this one was produced with that in mind. So this one eventually, although it didn't see much service around England because the war had finished for us anyway, but it was still going on in the Pacific. There were a lot of them were shipped across to the Far East and Middle East, and they ended up doing duties up and down the islands that the Japanese were being moved out of by the Americans and the English and the Australians and New Zealanders, and as a result the New Zealanders took a large number of these for their coastal defence and for surveillance, and a lot of them ended up in private hands. So again, I had to find, before I built it, the plans and the details of it, and I was very, very fortunate because I am in touch with the historic flight manager at Yeovilton, a chap called Mr. Wood, and he said come over because I'd built a swordfish, so I already knew him. And when I got there, he introduced me to their research department, and the research department brought out of their archives the original pilot's handbook, which I had to handle with cotton gloves because it is the only one in the world. So they kindly reproduced for me from its pages the cockpit details, the cockpit, everything that I needed, float sizes and all the hatches, and gave me a beautiful 3-view drawing. So I was now able to start construction of this. Now this one is of a different principle than a built-up wing because of the time that I started it in the year. So I got Pat Teakle of Pat Teakle Foam Wing fame to cut me 4 panels, and I cast fiberglass tips, fiberglass floats. The cowl was fiberglass, and in that is the 74 Zenoa twin boxer, and all the control switches are in the little hatch in front, as you can probably see. And the pilots again, 2 of them, quarter scale, are from AH Designs, and the propeller again is from Eats of Wales. Flying wires from Mick Reeves. It's just a flat flying wire with a turnbuckle at each end, and there's 2 on each side of the upright stays. Plywood body complete on a frame of quarter by quarter hardwood, and the tail is bolstered at the top but fabric underneath, which of course was not a good idea, because if you put balsa on the top of a wing, the balsa will stay as it is and gradually start bending, and you can just see that happening on the shot there. Again, Futaba gear with high-tech servos. SM Services Opto system. Now the Opto system, for those that you don't know, is a device which gives you 6 volts on your servo drive motor and 4.8 on your radios with your signal. So you've got 2 batteries, which gives you more duration time, and it's safer because the voltage drop out on the wings from a 4.8 battery is considerable. So your servos are really working very hard on a very low battery. Some of them even only 3 volts, and they should be 4.8.
In general aviation, the biplane configuration has remained popular. The American Starduster II was designed as a 2-seat sport aeroplane. This half-scale model, built by Greg Hayfield, has a wingspan of 12 feet, weighs 130 pounds, and is powered by a flat-twin Westlake engine of 342 cc. The engine mounting system, using steel tubing with adjustable rose joints, is exactly as per full size. This impressive piece of engineering provides a secure yet fully adjustable mounting. Most of the airframe is constructed from plywood together with spruce stringers and spars. Fiberglass is used for the nose and wheel spats, and aluminium sheeting for the engine compartment covers. Radio control is by Futaba, with 2 onboard receivers and no less than 11 heavy-duty servos powering the flying controls. There is always a very good reason why modelers choose to build a specific aircraft. Sometimes it's because they have always liked the aircraft, but now and again it transpires that something has happened in their younger days. This was certainly the case here. When Greg was naught but a lad, he happened to be working for an aircraft maintenance company at Marston Airfield in Kent. And lo and behold, there happened to be a full-size scallop hangared there belonging to a flying instructor. The incident follows the well-known storyline. "Hello, young man," said the gent, with the little lad gulping at this shiny new aeroplane. "Hello, mister," said the lad. "Can I have a go in your aeroplane?" "Ah," replied the gent, "jump in and I'll take you for a trip." And from that moment, Greg was in love. In the 1930s, the monoplane started to gain popularity over the biplane, especially in the military sphere. It was during this time that many aircraft design became the famous warbirds used throughout the World War II. In Britain, the Hawker Hurricane was the first of the new generation of fighters. It was this aircraft which bore the brunt during the Battle of Britain against the superior Luftwaffe Me-109. The Hurricane, in fact, shot down more enemy aircraft in that air battle in the skies over southern England than the Spitfire, which always tends to get the greater credit. The Spitfire, which was developed just a little bit later than the Hurricane, eventually arrived on the scene in sufficient numbers to make a significant impact. The Spitfire, a name incidentally disliked intensely by Mitchell, its creator, proved superior to the Hurricane, in particular speed and climb rate. When Adolf Galland, the top German fighter ace, met Hitler during the latter stages of the Battle of Britain, Hitler asked him what he could do to help the Luftwaffe. Galland answered, "Give us Spitfires." Hitler was not pleased. One of the early attempts to design a fighter aircraft was the Supermarine S-224. complexities and ultimate failure of this aircraft are again described by Roger Bale.
Hi, I'm Roger Bale, a model aeroplane pilot since I was at least 12, but of late, since I retired, I started building larger models, as you can see. And this one is the original, what was called Spitfire by the ground crew, and Mitchell built it down at Southampton after he had received a specification from the RAF called S224. Now, this aeroplane doesn't exist anymore. In fact, it was a failure. The original one flew at 15,000 feet, but it took 8.5 minutes to get there, and by the time it did, the steam condensers along the wings, which you can see here, were so inefficient that the engine went into the red and started to seize up. Not only that, but the condensers on the front wings heated the wings so that the ailerons jammed up. So here was a pilot flying in 1934 this prototype aeroplane for the RAF, hopefully, and he couldn't get it back down again because he had no ailerons, and eventually he had to stooge around in the sky until the wings cooled, and then he was able to land it. And his first remarks to Mitchell, who of course followed on with the famous Spitfire, were, well, if you want anybody to fly it, I would suggest you do it yourself, or words of that ilk. Now, this one is a direct descendant in replica of it, and it is a quarter scale. That means to say it's 4 times smaller than the original one. And this one here has a Zenoa, which is an American twin-cylindered, petrol-driven aeroplane. It has a 2410 prop on it, and the weight of it is approximately 39 pounds. I should say 38 pounds plus the fuel when it's loaded. It takes a 16-ounce fuel tank. It has servos on the ailerons, 2 on the elevators, 1 on the rudder and 1 on the throttle. I fly this with Futaba gear with the high-tech servos of the 600 range. At this present moment in time, I've discovered that the plastic teeth high-tech servos of the 600 range are not man enough for the back end of the elevators. In fact, I've had 2 servo trains strip, so I'm now going to go over to the metal teeth ones. Now, all the little ribs along these steam condensers, I had to decide how to make them. Unfortunately, before I started building, I did a lot of research. Now, one of the things that modelers find extremely interesting is researching a model before they even build it. And I managed to get in touch with the Southampton Supermarine Museum, and the volunteers down there did a fine job, and they posted me back the original photostat of the original plan of Mitchell of this particular model. And it was very, very good because they even photostated me quarter scale photographs of these steam condensers. So I was able to cut balsa and glue each one on. There's 280 strips, and it took me something like 2 weeks to do. All the rest of the model, body-wise, is balsa and 32nd ply. The wings are built up of balsa and with spars of quarter by quarter pine spruce. Leading edge is balsa, and the wheels are just ordinary 9-inch pram wheels. So you see, a lot of things that you can get for modelling nowadays are relatively low cost if you look around. In fact, I think most modelers are looking everywhere for something for their model. You know, I've just been round the Bring and Buy down there. Unfortunately, there's nothing worth buying. Now, that is the main details of the S224, which, as I say, the ground crew called the Spitfire. And Mitchell, when he heard this, said, "What a bloody silly name." But of course he didn't know that when his next design, which he worked in conjunction with Royce of Rolls-Royce, his Spitfire with the elliptical wings, a larger wing, shorter wing. It was built almost on the stall for aerobatics for a fighter. This one wasn't. This one's more like a glorified trainer.
In order to train a new generation of pilots for the new, fast and basically unstable fighters, new trainers had to be developed. The Mars Magister was one of these, and this exciting half-scale model, the creation of John Townsend, illustrates the type of aircraft required. The Mars Magister went into service with the RAF in 1937, and unfortunately it had a serious fault, especially since it was intended as a trainer. The aircraft could, when side-slipped, drop its nose and enter an unrecoverable spin. After 2 pilots were killed, the rudder height was increased and anti-spin strakes added to the fuselage. And although this improved matters, it didn't completely cure the problem. Built at 50% of full size, John's model weighs in at a hefty 165 pounds. It has a wingspan of 17 feet and a length of 12 feet 4 inches. It is powered by a German King inline twin of 190cc and fitted with a 34-inch by 10-inch ring prop propeller. The engine compartment is enclosed by genuine hand-beaten aluminium service hatches. Radio control is by Futaba, with 4 sailwind servos on the ailerons, 4 more operating the flaps. 2 even bigger servos control the elevator, with another for the rudder. Meanwhile, standard Futaba servos operate the throttle. All are controlled through twin receivers with split functions. Separate batteries power the receivers, servo and ignition. This attractive model took John 5 years to build, during which time he was able to climb all over the full size in the Shuttleworth collection while it was being restored. In doing so, he took over 200 colour photographs. He followed closely the method of construction of the original. The model, however, has 2% washout on both wings. The model replicates exactly the flying characteristics of the original. As the Second World War loomed, Germany was by far better prepared than Britain. It had been secretly developing all forms of military hardware from the early 1930s. In particular, its range of aircraft was much more extensive. In addition, its pilots had gained a great deal of battle experience when Hitler lent his support to General Franco during the Spanish Civil War. The main German frontline fighter was the Messerschmitt 109, of which over 33,000 were made. It was a lethal adversary, especially when flown by a battle-hardened pilot. This superb 1/3 scale ME 109 E4 is the handiwork of Fred Jackson. This model also featured briefly in the 2000 programme, but for this year it has been fitted with a larger and more powerful engine, the 3W 150cc inline twin. This powerful engine is well able to pull this 65-pound aircraft around the sky with comparative ease. What really enhances this model's flying performance is the deep growling exhaust, which was also a feature of the full-size aircraft, a sound dreaded by Allied soldiers as they tried to make their escape from Dunkirk. full-size aircraft, which Fred chose as his subject, was flown by Oberfuhrer Richard Skiffar, the wingman of Adolf Galland. On the 15th of November 1940, Skiffar was involved in a dogfight with a Spitfire, during which he sustained critical damage. He was able to land his aircraft at RAF Eastchurch, where he was taken prisoner. The Messerschmitt was later repaired by the RAF and used for flight evaluation. Fred is one of the most experienced LMA display pilots and is a self-confessed warbird nut. He always gives a polished performance, with his models performing only those aerobatic manoeuvres of which the full-size aircraft was capable. The next aircraft we meet is the de Havilland Mosquito fighter bomber. This impressive model is new to the LMA display lineup and is described by its builder and pilot, Gordon Nichols.
Okay, right, my name's Gordon Nichols, and the model you can see behind me is a Mosquito. It's a Mark 6 fighter bomber. It's the scale is actually 3.5 to 1, which gives it a wingspan of approximately 15.25 feet. It's built very traditionally, much like the full size, which is balsa wood and plywood construction, with exceptions of the wings, which are basically white foam and veneer, which makes it a lot easier for handling with a large model when you're in and out of big vans all the time, and trying to put them in hangars on a night time where there's too many aeroplanes and not enough room. So as I said, the basic construction is balsa wood and plywood, the same as the full size. It's built basically off of full size drawings, and all of the hinging and control surfaces and dimensions are all exactly the same as the full size, so it should give a very close what's the word I want?
Flight characteristics.
That's very good, I like that. Flight characteristics of the full size. There's no full size Mosquitoes flying now, sadly, so this is probably the nearest you're ever going to get to seeing a Mosquito fly. It's powered by two 3W120 boxers at present. Whether we're going to change them at a later date, we're not sure yet, but that's what's powering at the moment, which is giving adequate power, not overpowered. The model's a little bit heavy, 170 pounds in weight, which gives it a wing load of about 4.6 to 4.7 pounds per square foot, which is fairly heavy for a model. It's got, I can't remember the exact number of servos, but I think it's something like 19 servos in there. Most of them are rather large, so there's a lot of batteries in the front to power all the servos. In fact, there's not 10 battery packs in the front of the plane, and a host of avionics. Flying the Mosquito is something I've always wanted to build and do since I learnt to fly some 10 years ago, and finally actually, as you see, got it finished. Flying it, it's an absolute dream in the air to fly as the full size was. Takeoff is interesting to say the least. It does weathercock very badly unless it can go into wind, and even then it can be difficult on a good day. But once you finally get it airborne, it certainly makes up for it once in the sky, because it's
Ladies and gentlemen, what a start turning is. Sorry about the music, but we get that sorted tomorrow. Give them a big round of
Whilst the Mosquito was being displayed at the Southport Model Air Show at the beginning of July 2001, Gordon was approached by a man and his wife. It transpired he had been a World War II pilot and had flown Mosquitoes. Not only that, but he had flown the actual aircraft as modelled by Gordon. This type of occurrence has happened before, but this time the video camera was present to record the occasion. Needless to say, Gordon quickly subjected Stan to a fifth-degree debriefing to find out as much as he could about his wartime experiences and what Stan's impressions were of the Mozzie, both full-size and model. Stan had even brought along his pilot's logbook, which included all of his flying hours, initially on Bristol Bullfighters and then on Mosquitoes. He also showed his personal copy of the Mosquito instruction manual. It transpired that Stan had flown hundreds of hours in various Mosquitoes, including many strafing and low-level bombing raids over occupied Europe. One in particular was over Denmark, where the resistance were being systematically captured, interrogated and tortured by the Gestapo. The Danes had contacted the British for help. Their request was for the RAF to bomb a small group of buildings and a university complex at Aarhus on the east coast. To complicate matters even further, the Mosquitoes would, in order to maintain the element of complete surprise, need to fly low, in fact very low, at 50 feet over the North Sea and across the breadth of occupied Denmark in daylight. The buildings identified contained the Gestapo staff quarters, but more importantly, all the files containing names and other information on the Danish resistance organisation. The problem was that there were Danish people in the adjacent identical buildings. These photographs, provided by Stan, were taken from a camera mounted on the tail of his aircraft and show the successful raid in progress. The ground photo, taken later by a member of the resistance, shows the result of the raid. Both Stan and his wife, who obviously enjoyed the occasion at the Southport event, were later given VIP treatment during the Woodvale rally. The Mosquito, being a fighter bomber, has conveniently bridged our story from fighters to bombers. It is probably in the wartime development of the bomber in which the greatest advances of aeroplane took place. In the early stages of World War II, most bombers, both German and British, were relatively small and had rather limited performance in speed, range and in particular in bomb load. Of all the early British types, it is fair to say that only the Vickers Wellington was really successful. John Greenfield, who is the Chief Examiner and Safety Officer of the Large Model Association, will now describe his latest creation.
Good morning, my name's John Greenfield and I'm going to tell you today a little bit about this here Wellington bomber of mine. I built it about 2 years ago now. It took me 3 years for the construction, which for a model of this size seems quite a long time. But underneath this skin is a true geodetic construction, copied from the original Vickers drawings and also with a great deal of help from the guys who pulled Arthur Robert out of Loch Ness some years ago, the aeroplane that's now back in the Brooklands Museum. In order to build it in a true geodetic way, we had to take one minor compromise, and that was to make it out of wood and not out of metal. Believe it or not, wood was actually stronger in the sizes we needed, weight for weight, than metal would have been. But in order to build the aeroplane in the geodetic form, first of all we had to make up a series of jigs, exactly the same as they'd done with the full size. These were made in the time-honoured model method of cutting a foam wing, but then throwing away the foam wing and using the outer shell in order to form the geodetic structure, which was actually built from the outside inwards. In order to build the wing, there's actually 16 individual jigs. Because of the taper of the wing, you can't hand the jigs, so they're all done individually, and then 4 more jigs were built to enable all the sub-assemblies to be put together. So now you can see why it took 3 years to build. It took about 6 months to build each outer wing panel. The tail and the fin are all done exactly the same way, but we did have to cheat a little bit on the fuselage because I couldn't get a geodetic structure to be torsionally stiff enough. But on the full size, the geodetic structure on the fuselage is actually overrun with stringers, so we put scale size stringers in the scale locations to solve that problem. The engines on the plane are 2 3W 60cc single-cylinder engines, which for a plane this size is actually quite small, but it only weighs 50 kilos due to its lightweight construction, and therefore the engines are more than adequate. In terms of the systems within the plane, of course it's got all the normal flight control functions, retracting undercarriage flaps, landing lights that work, and also wheel brakes. Because one of the things I found with models with wheels this big, and these are 10-inch diameter wheels, is that on a runway there's not enough rolling resistance for the plane to naturally come to a stop on its own. So I built into the wheel hubs twin leading shoe brakes which are pneumatically operated. Because of the fear of the amount of air we would use up with the retracts, which incidentally have got 45mm diameter pistons to give huge amounts of reserve of power, I put an onboard compressor on the plane, connected up via a pressure switch, so it actually looks after its own pneumatic systems. If the pressure's dropping too low, it fires itself up and just pumps the things back up again. So I can fly around for as long as I want, making the wheels go up and down or using the brakes as much as I need to, and no problem at all, never run out of air. The aeroplane's done a whole heap of flying now. I'd never keep a tab of how many flights it's done, but 2 full seasons worth, plus some film work, plus a load of flying on my club field. I've even actually used it with a buddy box as an incentive for some of the people in my club who've passed the BMFA A test. Basically, if they pass an A test, I'll let them have a fly of it on buddy box. It's so docile to fly, it's just wonderful. That's it, I enjoy it. We're here at Woodvale this weekend. Hopefully the weather's going to stay nice, and you'll see some more flying shots of it later.
Now another Wellington, described by its creator, Andy Johnson, one of the younger stars in the LMA display team.
My Wellington, I built last year. It's actually built from the remains of one that the Liverpool club had that crashed 2 years ago at Cosford. I joined the Liverpool club flying team early last year. They've been trying for a long time, for over 5 years, to fly 2 Wellingtons together, and it's never happened. Every time they've got one flying, the other one's crashed, and vice versa. So I joined the team and took over the repair or rebuild, which is basically a new aeroplane. I saved the outer panels and the tailplane, but the rest of it's a new aeroplane. It's owned by the Liverpool club. They paid for everything for it, the same as the other one. It's 18-foot span, weighs 120 pounds, and so far I've had 25 flights with it. It's had no problems at all. It flies absolutely superb. The retracts in the aeroplane are made by Ray Slack. Same with both Wellingtons. They've been superb ever since I've had them, no problem at all. They've been through various crashes and survived all of them. Radio gear again, I use the Zap 9 on that. I'm running 14 servos. No special features as such yet. I've never got round to. I've got lights to put in it, which I've not got round to. And the Bombay again is something that I'll be doing for next season. I've had various people help me with this one. Again, also with my B-17 was the same. I've got a lad called Stuart Lunny, who's in the Liverpool club, who's very good with painting. He did the finishing touches with the weathering and various details. There's also another lad called Phil Cummins, and his friend Tommy, who's done quite a bit of work with it as well in the building and general construction. And there's altogether there's 5 of us. There's my brother-in-law as well, Ian Porter, who's worked on it.
It has long been a feature of the Woodvale Rally to end the show with a simulated low-level bombing display. The 2001 event was no exception. The Wellington bombers, together with a fighter escort, provided what was probably the most realistic display to date. After the Americans entered the war, there was a distinct improvement in all aspects of bomber design. They not only produced larger aircraft and thereby improving the offensive capability, they also considerably improved their defensive capability. It was no surprise when the Boeing B-17 became known as the Flying Fortress. Again, we meet Andy Johnson, who with his father Dave, Gordon Nichols and Richard Rawle always produce a show-stopping display.
Hi, my name's Andy Johnson. I fly the B-17 at Aberystwyth. It's an aeroplane that I've always liked from being a young child. When we first got into flying model aeroplanes, me and my dad, we built a 6-foot one that we did the Aberystwyth colours. I always said if we made a bigger one, then I would do it in the same colours. It all came around originally through Richard Rawle, who had been doing some work for the TV company down in London. I'd been looking in the hangar where they keep all the props and whatever, and found the moulds. He gave me a ring to say that he'd got the moulds and was he interested, and I said I was, and the team got together and decided to do half a dozen. We've managed to get 4 flying. The other 2 lads lost the interest to do him. Still got them in the half done with the idea of flying them in a couple of seasons' time when they finish other projects. It's powered by 4s and all 38s, weighs 120 £. The retracts were made by a friend of Gordon Nichols down at Bristol. He's an engineer and does it as a part-time job, makes retracts for model aircraft. Okay, the radio gear I'm using is ZAP9 from Taba radio gear. I'm running 13 servos. It runs on two PCM receivers with opto-isolators and SM services. Also has battery monitors, SM services and their switches. In fact, actually the whole system really was made by them for the aeroplane. The wiring that I use is actually from a computer shop. It's a heavy gauge wire that's screened to cut out any interference, which I've had no problems at all with. Using 4 battery packs to 4,000 6-volt packs running the servos, and to 600 milliamp 4.8 battery packs that run the receivers.
The Fortress was quickly followed by another great American bomber, the consolidated B-24 Liberator. Here we meet John Deacon for a fascinating description of the full-size aircraft and of his magnificent model.
Hi there, my name's John Deacon. You've probably just seen the Liberator flying. I chose to build the Liberator model basically because a friend of mine was building a B-17 model and he suggested I build another one along with him. And I said, oh no, I don't want to do that because I prefer the B-24 Liberator. It's a model I've always wanted to build. So that's how the project started. The model took 3.5 years to build, over 1,700 hours. It was started in October 1995 when I got back from a holiday, and the first thing I had to do was register it with the Large Model Association, because in excess of 20 kgs models have to go through an inspection process which is run by the LMA in conjunction with the CAA. The registration process then takes you on to being allocated an inspector whose responsibility is to ensure that the design is satisfactory, the building is of a suitable standard, and the model is sufficiently strong for the way that you are going to display and fly the model. The model is built from standard materials. It's light ply, balsa wood, birch plywood and glass fibre. Glass fibre is used in the spar material, also using Paxilin. Construction is totally conventional, standard adhesives, polyester resin or epoxy resin and PVA glue and a little bit of cyano. The model was designed from scratch using a 72nd scale plan that I found in an Aviation News magazine, and as I say, it took about 3.5 years to final completion. There were an awful lot of hazards on the way, but when you start on a big project like this, you expect to meet some serious obstacles, and sure enough I did. The model is based on a B-24 that was flown by the US Army Air Force in the Second World War, namely the 458th Bomb Group, who were based at Horsham St Faith in Norwich. The aircraft is a consolidated B-24H-25FO, which means it was one of the 25th batch built by the Ford Motor Company in Detroit in Michigan. This particular aeroplane was one built in March 1944 when they went over from camouflage olive drab paintwork to natural metal finish. They did this in order to save weight, paint, cost, and of course at that time of the war, when the formations over Germany were sending out big contrails, there wasn't an awful lot of point in having camouflage finish on the aeroplane. This particular machine was based at Horsham St Faith with the 755th Bomb Squadron, and it was flown by Captain John L. Olam, and coincidentally he came from the same town in the United States as did the crew chief, Master Sergeant J.R. McGinn. Their hometown was South St Paul, Minnesota, and in that town was a club called the Hook 'em Cow Club, and so they decided it was a wonderful name for the aeroplane, hence the name Hook 'em Cow. On the starboard side of the nose you will have noticed that the artwork is Stinky. Now this is because the lady portrayed on the starboard side of the aircraft is a portrait of the captain's wife, and Stinky was her nickname. I don't know how she got the nickname, of course, but that's how it came out. The actual Hook 'em Cow aircraft came over to this country in the summer of 1944, and having been based with the 755th Bomb Squadron was transferred to the 754th Bomb Squadron in late November 1944, and its final mission took place on the 14th of April 1945 when it was destroyed on takeoff on a flight to Bordeaux. The crash occurred near a house near the airfield, and the situation was that shortly after takeoff the port inner engines started catching fire, and it was obvious the aircraft wasn't gaining height. The aircraft continued to struggle round to try and get back to the airfield and hit a power line. There was a big explosion and it crashed in the grounds of a house near the airfield. There were 2 survivors from the 7 crew. 5 crews were killed, 3 of them were buried at Madingley, and 2 of the other bodies were sent back to the United States. That in fact was the 55th flight of Hook 'em Cow, and it crashed on that flight and was totally destroyed. The model, the specifications of the model might be rather interesting. The model is 1/6 full size. The full size is 110 feet, therefore the model is 220 inches, which is 18 feet 4 inch wingspan. The construction, as I said, was perfectly standard. The covering is of interest. The balsa sheeting over the whole airframe was covered with glass fibre cloth and epoxy resin, over the top of which was stuck lithoplate, which is a thin aluminium sheet produced for the printing industry. The sheet is 6 thou thick or 0.15 millimetres thick, and it was cut into appropriate sized panels. The rivets were produced by turning the sheet over and impressing the rivets with a dressmaker's star wheel, which is a small device like a cogwheel that you just run along the edge of a ruler. It was quite straightforward to do. The only difficulty with the lithoplate was the compound curves, where the lithoplate had to be softened. The radio equipment is Graupner JR6 MC1620. There are 22 servos. There are 8 quarter-scale servos for the main flying controls and other miscellaneous servos for the rest of the aircraft. The undercarriage, the main undercarriage units are pneumatic, fully retractable of course. The nose wheel is electrical retraction using a Mick Reeves giant scale servo. The steering on the nose wheel is with a metal gear servo, HS615, and the other standard servos are used for air valves, throttles and miscellaneous items. The engines are Zenor 45 2-stroke petrol engines, each developing 3.5 horsepower, so the total power is 14 horsepower. The propellers are 2-bladed 22 by 8 wooden props, carefully balanced of course. The fuel system, each tank is a 32 ounce tank, which is 950 millilitres. At full throttle, the engines consume just over 1 ounce per minute. Therefore, I would get at full throttle at least 20 to 25 minutes flying. The flights that you see here were taken at Cosford and were average 10 minutes duration. If you allow a 2 or 3 minute for start-up, run-ups, fail-safe checks and taxiing out, I've got a good 10-minute reserve upon landing. The 6 main controls are the standard controls: ailerons, elevators, rudders and throttles. All 4 throttles run off the same throttle stick. 2 auxiliary functions, of course, retractable undercarriage and flaps.
The Germans led the way in transport aircraft, the Junkers Ju-52 being specifically designed for delivering paratroops. Here, John Menhennet describes his model of this unorthodox aircraft.
Hello, my name is John Menhennet, and I'm going to talk about the Ju-52, which I built with the help of Stan Bazant, a friend of mine, 2 years ago now. It's quite a quick project, this one, because we built the whole thing in 2 months. It's constructed from white polystyrene foam, covered with obishi veneer, and then we've got this ABS covering. The span of the plane is 14 feet. It weighs 44 pounds, and it's powered by 3 laser engines. There's a 180 laser in the nose and an 80 laser in each wing. The electronic gear is JR. It's got 14 servos in the plane. The servos have all got metal gears. It's a tough old plane. Not only has it got this obishi veneer, but it's also got this ABS covering. And the way we decided to do the covering was to get some packaging corrugated cardboard, find a piece that's in good condition, and that cardboard then we stuck to plywood, and then give it 3 coats of polyester resin. That then gave us a tool that we could vacuum form these sheets of ABS. When it came to getting the finer corrugations, which is for the flying surfaces and the fin, that presented a problem because we had a devil of a job to find corrugated cardboard just the right size. This really was cured by one morning I went from the workshop out to the kitchen to make a cup of tea, and whilst waiting for the kettle to boil, I noticed that there was a jar of uncooked spaghetti on the side in the kitchen. And I looked at this spaghetti and I thought, I don't know, I reckon that's about the right size of what I want. So anyway, I tried it. So I got a sheet of plywood, and I got these strips, I got the spaghetti out of the jar and sorted out the straightest ones, and then stuck the strips of spaghetti side by side with a slight gap, zapped it on with the cyanide, then give it 2 coats of epoxy resin, and then this then made the tool to form the fine ABS corrugations. Obviously afterwards we couldn't eat the spaghetti. In fact, I still got it, it's preserved forever in epoxy. The plane flies very well. It's an absolute dream to fly. It's really just a big powered glider.
The Americans had quickly realised that there was money to be made from carrying passengers, although in their case they didn't initially think of the military use. The Douglas DC-3 Dakota was to become one of the outstanding World War II aircraft, and we meet Dave Johnson, who describes his Dakota, one of the largest models in the LMA display team.
Right, yeah, my DC-3, it's 1/5 scale. It was blown up from the Zeroli plans approximately 3 years ago. It did take 3 years to build, so it's actually 6 years ago we started it. It's powered by 2 Zenoa 62cc engines with converted electric starts by Ray Slack. Model flies very, very nicely. It's had now approximately 120 flights in the 3 years. Yes, I say it's 21'6" wingspan, which is a 5th scale. It weighs 120 pounds exactly dry. It flies very realistic. It's really been my best model for the last 3 seasons. I've only flown it probably about 40 flights a season. I do enjoy flying it. It's quite, it's got scale undercarriage, scale working undercarriage, which was built by some friends of mine. That took some time to build. It's foam construction mainly. It's got veneer covering and then Solatex covered. It was sprayed up in the colour scheme which it's in at the moment with Johnson Airways on it, with the intentions of making it into Southern Airlines, which is exactly the same colour scheme. But I got quite used to the idea of having my own name on it, and it's we've never altered it as yet. When it ever has a refit, we probably will do then.
Man's inherent competitive nature has ensured that from the time when sustained flight had been achieved, a totally new world of sport and competition was conceived. New records were there for the taking. Initially, the records were associated with distance, then speed, and later altitude. At every stage, man was exploring new situations, often with terrifying experiences. As airframe and engine design progressed, a new sport blossomed, that of aerobatics. We have already seen the Bucker Youngmeister, which in the 1930s set new standards in design, construction, and in particular in ease of handling. Later, during aerial combat during World War II, many of the aerobatic manoeuvres became part of the repertoire of the ace pilots as he attempted to gain advantage over his opponent. The models replicate the flight characteristics of their full-size counterparts, and with the added visual effect of trailing smoke, such displays enter the sphere of aerial ballet. Just as in full-size aerobatic displays, the synchronized flying of 2 or more model aircraft is extremely difficult to achieve. Hopefully, a band of flyers will eventually eliminate all the difficulties, and then we will all be entertained by a fantastic Red Arrows display team in miniature. At the show held at RAF Cosford, the LMA had once again invited Ludo Leuten and Tang Frans to bring over their superb half-scale models from Belgium. Last year, the Sukhoi was featured. This year, Ludo demonstrates the Christen Eagle. This wonderful aerobatic biplane is powered by a 400cc microlight engine. Ludo's masterful display of aerobatics is presented perfectly to a most appreciative audience. The incredible sound of this immaculate model brings an additional quality to a stunning display.
Look at that shot there, everybody. Oh, come on.
As was stated at the beginning of this programme, the models featured would replicate the development of aircraft over the past 90 years. Although not a scale model, this Kangaroo, flown by Dave Johnson, demonstrates just how far technology has developed. The American-built turbine develops 29 pounds of thrust, whilst the rotor spins at up to 150,000 revolutions a minute. The startup procedure is controlled by a laptop computer, which ensures that the turbine is started efficiently and safely. First of all, the turbine is spun up using a small electric motor. Then propane gas is injected and ignited, and once the correct operating temperature has been stabilised, the kerosene fuel is turned on. All this is prompted by the computer, and once the engine is running correctly, control of the throttle is given to the pilot. The performance is stunning, especially in such a slippery and agile airframe. However, with maximum airspeeds in excess of 250 miles per hour, the pilot's skill and concentration become the limiting factor. Additionally, such high speeds can quickly overload airframes and flying controls. A number of jet turbine models have unfortunately been written off. Ron Burnett, one of the finest jet pilots in Britain, flies this F-15 Eagle, built from a Belgian kit. The airbrushed graphics on this model are quite exceptional. The startup of this aircraft is more advanced and automated than even on the Kangaroo. With this system, the computer takes complete control, automatically moving through the procedure. The flight performance of this model, with more than 30 pounds of thrust, is to say the least exciting and mirrors that of the full-size aircraft. Even the jet blast closely resembles that of the full size.